Imagine you're sipping your favorite bubble tea when suddenly the straw starts spitting out boiling magma instead of tapioca pearls. Nope, it's not the latest TikTok trend. It's the geological version of a giant lava lamp hiding right beneath your feet. Welcome to If Only, the channel where we turn science into memes, scientifically accurate ones, of course. Today, we're diving into what would happen to Earth if a continental plume, the brand new Dani Plume, decided to come out in explosive style. What is a plume, anyway? Let's start with the basics. What on earth is a plume? No, it's not the latest overpriced smoothie flavor. A plume is a channel of superheated material that rises from the very bottom of the Earth's mantle. We're talking about 2,900 kilometers deep, all the way up, sometimes punching through the crust. Think of it as a planet-sized lava lamp, but instead of just glowing on your desk, it sculpts continents and fuels volcanic chaos. The Earth's mantle is like a giant frying pan that's been cooking for 4.5 billion years. That heat tries to escape, very slowly, through convective currents, and plumes are the hot express elevators of this system. These convective motions aren't some boring textbook trivia. They're the hidden engine of plate tectonics, continental drift, earthquakes, volcanoes, basically all the Earth's best action scenes. And plumes are the unsung heroes, or the hidden villains, depending on your perspective. Why is the Dani Plume a geological rock star? The latest superstar in Earth's deep core fanbase? Meet the Dani Plume, recently discovered beneath Oman in the northeastern Arabian Peninsula. So why all the fuss? Because it's a continental plume, and those are rare. Oceanic plumes, like the ones that created the Hawaiian Islands or the Azores, are more common. That's because oceanic tectonic plates are thinner, making it easier for magma to push through and say, "Hi, I'm hot and I'm here." Continental plates, they're thicker and tougher, kind of like the crust on a sourdough pizza. That makes it way harder for a plume to break through, which is why continental plumes are like the unicorns of geology. What makes Dani even more epic is that it has no volcanoes on the surface, no lava fountains, no warning lights. Scientists pieced together its existence using seismic waves, sedimentary records, and advanced geodynamic modeling. And here's the jaw-drop moment. Between 45 and 25 million years ago, the Dani Plume physically deflected the Indian tectonic plate's path. That's like a deep earth invisible force steering a continent like a bumper car. Mind blown. What if the Dani Plume suddenly woke up tomorrow? All right, time to fire up the imagination. This is if only, after all. What if the Dani Plume suddenly reactivated tomorrow, full force? Here are 4 explosive, but totally science-backed, scenarios, volcanoes in the desert. If magma started to rise, we could see volcanoes erupting in Oman. Picture lava fountains among the dunes, like Hawaii meets Mad Max. B. A new rift in the Middle East. If pressure builds, the continental crust could crack, just like what's happening in the East African Rift. The Arabian Peninsula might even begin splitting off into its own mini-continent. Climate impact volcanic activity could pump CO2 and aerosols into the atmosphere. Enough of it, and you get a temporary cooling of the global climate, what scientists call a volcanic winter. D. Geothermal gold mine. If we harness the Dani Plume properly, it could power entire cities with geothermal energy, a clean, renewable energy source right from the Earth's angry core. Why this discovery actually matters to you. You might be thinking, cool story, rock nerds, but how does this affect me? Well, it actually matters a lot. Knowing where plumes are helps us predict earthquakes, volcanic activity, and even the future of continents. It teaches us how heat and matter move inside the Earth, which also affects climate, sea levels, and continental formation. And, plot twist, there could be many more plumes hidden beneath our feet, just waiting to be discovered. And the coolest part, Scientists found Dani by connecting data that seemed totally unrelated: seismic waves, old sediments, tectonic plate movements, proving that sometimes science works like a giant detective story, just with more magma and fewer trench coats. In short, the Dani Plume is like that quiet roommate you suddenly find out is a techno DJ at 3 a.m. Up until now, no noise, but it might just throw a planetary party with quakes, volcanoes, and bonus geothermal energy. Geology 1, Superficial Thinking 0. If you want more explosive what-ifs, hit that subscribe button and ring the bell, so you'll be the first to know what would happen to Earth if we left science unsupervised. See you in the next impossible, or almost possible, scenario. And remember, Earth may have a boiling